should be ready to go.
Great, thanks so much. Okay, so today is the first of our workshops focusing on visitor use management and monitoring parks and protected areas. And we're going to focus today on mobile device and big data. Becky gave some of this project background, but I'm going to talk a little bit more about a little bit of the background of this project, why we're focusing on mobile device data and big data today, and define visitor use management for folks. So again, this is part of a broader project that was looking at visitor use management and monitoring at Big Basin Redwood State Park as kind of a place to start to think about how we might apply the visitor use management planning framework to state parks, parks and protected areas, and their visitor use management. From that project, we then were able to think about some topic areas that might be relevant for statewide training, issues or topics that applied across state parks that could help inform how folks might monitor visitor use, how they might estimate attendance, and think about monitoring other types of resource or visitor use experiences. And just to make sure, I'm going to be using the term visitor use management quite a few times throughout this presentation. So just to make sure we're all on the same page, the Visitor Use Management Council that developed the framework that Becky mentioned defines visitor use management as kind of a proactive and adaptive process for managing desired conditions related to both resource conditions and the visitor experience. A component of visitor use management is also monitoring those resource conditions and the visitor experience, and often also how many visitors you might have coming to a park or protected area. So we're talking a little bit about that monitoring and visitor use estimation piece today when we're discussing big data. And the focus on big data did come out of this statewide survey. So there was a statewide survey that was sent out to state parks. Folks talked about the types of issues they were facing, different types of resource conditions they might be thinking about monitoring, questions around monitoring visitor use levels. And one of the things that came out is that there was an interest and potential for using big data, like mobile device data from cell phones or crowdsourced data, to monitor visitor use. And so we felt that for today, we'd talk about what does big data mean in a visitor use management context? What are some examples of big data that have been used to monitor visitors or resource conditions in parks and protected areas? And discuss some of the opportunities as well as some of the limitations of these methods, some situations where maybe they might be better suited than others, and to go through a couple of case study examples of what we know from the scientific literature of what works well and doesn't work well with this big data. And then we'll end today with a discussion about where you all may see some opportunities for these data types for monitoring visitor use, and then answer any questions that you all might have. So we're going to start with a little bit of background by talking about what is big data and what does it mean in a visitor use management context. Often big data comes into a visitor use management scenario when we're thinking about using this data as a way to understand visitor use levels, visitor use patterns, and sometimes with some of the data types, we might also get a little bit of a sense of the visitor experience or visitor perceptions. I'll dig into that a little bit more once we get into the data types. So that's kind of the way big data comes into conversations with visitor use management. But to make sure we all have the same kind of like working definition of big data, I'm going to walk us through some of the definitions that comes out of the visitor use management literature. So big data is often defined as these large data sets that are often coming from secondary data sources. And the characteristics of big data is really the volume, the velocity, and the variety. So the volume means we're creating a lot of data very quickly, and there's a lot of different components to that data. So we think about social media, which we'll dig into deeper soon. That is being created all the time. Lots of folks are posting on social media, and it can be a variety of type of data. We can have photos, we can have geolocations with those photos, we can have explanations of why someone took that photos, we can have interactions between different users, and so there can be a variety within the data. So within a visitor use management context, the reason big data could be beneficial is because of these characteristics, right? We can get a lot of data from secondary sources that's kind of passively collected. So we don't need to go on site necessarily to estimate visitor use or to survey people. We can also get the data a lot more quickly than on-site methods potentially. And again, it has a variety of different data sources and data information that can be similar to the types of data that we can collect on site. And again, we have this passive participation. So we're not having to go out and recruit folks to take a survey or fill out a survey online. We don't have to go out and install trail counters. We're able to essentially scrape the data from other sources. And so that can make it a little bit easier in terms of time and resources in some ways. So that's where big data has really come into, is how do we understand our visitors without necessarily having to go on site and do a lot of on-site data collection. The examples of big data that are often talked about in visitor use management context are the top three I have here, and then I'll mention a few others that are coming up more and more. The three we're going to talk about today are social media data. The second one is going to be crowdsourced or volunteer geographic information, and I'm going to define all these as we work through the presentation. And then the third one is mobile device data. This has also been referred to as cell phone data or human mobility data. But for today, I'm going to use mobile device data because that's kind of the terminology that's been used with the folks that I interact most within this research. But when I say mobile device data, it's the same thing as cell phone data or human mobility data. And there has been some work recently also using reservation systems like rec.gov or other similar systems that you all may have in your parks as a way to kind of extract big data, where again, folks are sort of passively submitting that data to maybe make reservations. You can gather information from that. More and more vehicles, personal vehicles, have GPS or enabled with GPS, so that can be a source of big data. And then community science is another. So these first three are the ones we're going to go through in detail today. And then the last one, I'll come back to that fourth item at the end, and I'm happy to answer questions that folks have about those types of data sources as well. So we're going to start with social media data. And again, the point of each of these is to discuss what it is, the opportunities for visitor use management, some limitations, and then go through a couple of examples of how this data has been used in a park or protected area context. So I'm not going to make assumptions that we all know what social media data is, or that we want to make sure we have the same working definition. So social media data is essentially a user-generated content that's publicly shared on digital platforms. So users are creating it and sharing it and making it available to the public. Some social media data may have volunteer geographic information. This just means that there might be some geospatial data, an XY coordinate, a point we can put on a map associated with that posting, with that social media post. That's not the case for all social media data, but you can have that spatial data, and I'll show you some examples of that in a minute. Examples of social media kind of platforms where we can get data related to visitor use management are sites like Flickr. This is a photo sharing social media platform. Twitter, which is now called X, or X formerly known as Twitter, however you want to phrase that, and Instagram. So those are the most common ones that have been used in visitor use management thus far. So some opportunities with using social media data. Again, we can get information about our visitors from social media without having to spend time and resources in the field. So that is one benefit. They can contain spatial information. So when folks post a photo to Flickr, where that photo was taken can also be part of that data. So you can see kind of the spatial artifact of where folks have been. It can also contain contextual information. Often with social media posts, whether it be X, formerly known as Twitter, and people are kind of having a dialogue, or an Instagram where folks are posting a photo and adding a caption, there can also be some contextual information that can give us a little bit of info about, how people perceive their experience or why they might be drawn to a particular place and taking that photo. There can also be engagement between users. I saw a study recently where folks looked at the interactions on Facebook between manager, like Facebook accounts, and the visitors, and kind of the tone of how those responses were, to get a sense of the relationship between the managers and folks that were engaging with their social media. So we have that user engagement that we might not have from some of these other data sources I'll talk about today. And then again, this is publicly available, so it's relatively low cost. Typically, to access social media data, you're using an API or an application programmatic interface. So you have this API that allows you to talk to Twitter, allows you to talk to Instagram and pull the data that you need essentially. So often the costs associated with social media data is not, instead of it being like in the field where we might use traditional methods to collect the data, it's more on that back end, that post-processing. It's time and money of an individual to write the code, to pull the data from the website, to clean the data set, in some case, de-identify the data set, and run the analysis. So it's out there and available, so it's relatively low cost, but there's still that cost on the back end to use the data source. So situations where social media data might have some particular strengths or might be good situations to use this type of data are places where you know that the social media data is correlated with use. So some of the earliest research on using social media data in visitor use management context was looking at the correlation between on-the-ground counts and like the number of social media posts, to use the number of posts as kind of an indicator of use levels. And in some cases, there are very strong relationships. However, these relationships are variable. There's been some work that shows that lower use parks, or parks that don't necessarily have resources that are as, I don't know, Instagrammable or photographic, we don't have a strong relationships between visitor use levels and those social media posts in those parks. So you want to make sure that, do like a pre-test to make sure that your location, your use levels might be correlated with visitor use if you're thinking of using social media data as like a proxy or an index for use levels in some of your unmonitored sites. And if there's questions about that, again, I'm happy to answer those at the end. It's also really good if we're thinking about comparing broad temporal scales, so estimating visitor use at like weekly or monthly scales, or if we're really interested in some of the context, the photos, the captions, interaction between visitors that is unique to social media data compared to some of the other data types we'll talk about today. Limitations with social media data: it's not representative of park users. So it can be somewhat biased. We have different user groups that use social media platforms like Instagram compared to Facebook, right? There's age differences, there's demographic differences, and it's not representative of necessarily typical park users. And again, there's this kind of bias in postings where we get more engagement on social media with certain types of parks and protected areas that may be might create the type of content that might lead to more engagement. So again, really photographic places. There's also constantly changing privacy regulations and data availability. So for example, Instagram used to allow you through the API to get geolocations of photos, where photos were taken and where they were posted from. They kind of tighten their privacy in that you can no longer get that. So studies that use Instagram have to look at data from 2017 or previously and have already downloaded that. So it's constantly changing landscape in terms of what is accessible. And it's also important to choose the most relevant platform for your users, and also make sure you're doing some on-the-ground validation, be able to compare it to actual use counts. So a couple quick examples, and we'll move on to our second data type. This was a study done by some researchers in Australia looking at the relative popularity of different Australian beaches by scraping, so pulling photos data from Flickr. And again, Flickr has those geolocation data associated with us. So they were able to download over 32,000 photos that folks had taken at beaches in Australia between 2010 and 2019 and map them, and then basically figure out which beaches are more popular than others. So the red color, I know it's a little hard to see, but the red areas are more popular beaches, and the areas that are kind of in that lighter yellow. So it's not an exact use count. So it's not what we can really do with social media, but it's kind of an idea of relative use levels that we compare across sites. So what was interesting from this study as well is not only did they look at which beaches were maybe more popular than others, they also looked at the captions, the content, the text that was associated with these photos, and where the individual said they were from. So they're able to pull information about kind of the country that the person listed they were from with their photos, and be able to compare some of the text from Australian visitors to international visitors. So it's a little hard to see, but this side has all the different beaches. And then this solid line box is the survey, the responses that they coded for the Australian visitors, and the lower box is from international visitors. So what they did is they took the text and then they decided, okay, what is this text what is the emotion that the person is kind of invoking with this text? So colors in red here on the left, these are things where the text indicated maybe anger or fear or disgust. And then here on the blues, these are more positive feelings that were coded for the text with the photo: anticipation, joy, surprise, and trust. So we can see for most of the beaches and for most of both the Australian and the international visitors, overall, the feelings from the posts with the text associated with these photos was positive. But we can see this one beach, Fraser Island, had somewhat high kind of negative connotations associated with the photos for international visitors. So the social media data, again, can have this kind of contextual piece that we don't have with some of the other data types. And then I'm not going to go through this next example in a ton of detail, but this is a more recent study using social media data to predict visitor use levels and to look at that correlation between the number of social media posts and actual use levels in these parks. This pulled data from Flickr, Twitter, and Instagram and had the geolocated where that post was made, tied that geolocation to these different places. I'm sharing this one because a key takeaway from this study is that in some of our lower use visited locations, unmonitored locations, the best models incorporate some on-site counts and include some other variables like weather, holidays, days of the month. So a key takeaway from this paper was that the modeling of using social media as a way to predict visitor use levels, like how many visitors are coming to these parks and protected areas, the more sophisticated models tend to be performing better. And I bring this up because, again, the costs associated with social media data is often on that back end of doing the modeling, pulling in the data. And so this paper is really illustrating some of those key points. Okay, so that was social media data. We can come back at the end if there's questions about that. Now I'm going to walk us through another big data source that's common in visitor use management: volunteer geographic information, or sometimes referred to as crowdsourced data. So VGI, or volunteer geographic information, is data that's user generated that has geographic or spatial information. Now, again, some of our social media data does have geographic information, but for today, I'm really gonna kind of narrow down the VGI data to things where we can not just know where people are, but understand more about their behavior, like which trails they use, maybe how long they were out there. And so a really common source for VGI data in parks and protected areas and in visitor use management scenarios are some of our fitness tracking apps, things like Strava, AllTrails, Trailforks. These are apps where folks log essentially their run or their bike ride on a particular trail, and you can kind of get a little bit more behavioral data than you might get from a social media post, which may just be like a photo taken at one point. So a little bit different than social media data, but some similarities. In terms of opportunities, again, reduce time and resources in the field. It is publicly available and, again, low cost comparatively. And just to kind of show you what the publicly available data looks like for some of these fitness tracking apps, here on the right-hand side is the Strava heat map. All I did was open Strava heat map and looked up, this is from Crystal Cove State Park, and we can see the purple lines where visitors have uploaded their hikes or their bikes. And, you know, I've just zoomed in roughly to the area around the park. So you can see roughly where folks are going, which trails are more popular than others. But again, it's not an exact count of use. It's more like relative use levels. Like social media data, the cost is more on the back end, getting the data, analyzing the data, cleaning the data. You can get quite a bit from these apps, these fitness tracking apps, without having to do in the field work. These are better for broader spatial and temporal scales. So again, looking at like how long someone stopped at a particular overlook, or like people at one time counts, not really great for that. But again, understanding relative use levels across trail systems or at destinations this can be useful. And again, it's a relative use level. It's not an exact number of individuals, but it does give us a little bit about their behavior too. We can see again how far people go, how long they spend, which trails are most popular. In terms of strengths, if you know that your park is a big fitness or activity focused destination, then these apps can be potentially really helpful. So one of the studies that I've done recently where we used Strava in particular was in the Nature Reserve of Orange County. We had done a survey and asked visitors about their motivation. The top motivation for a lot of those parks was for fitness. So we felt that because of that, Strava might be a good proxy for visitor use for doing some trail-based modeling. And again, it's best if we're trying to compare use levels or compare patterns of use as kind of like an indicator of overall use versus trying to estimate our like absolute attendance. The limitations are somewhat similar to social media data. The representativeness. Not everyone is out there using Strava or Trailforks or AllTrails when they're recreating in our parks. Some recent work has actually looked at the bias with Strava. Strava in particular tends to underestimate use by women, by older generations, and by much younger folks like teenagers and folks in their 20s. And again, it's very user group specific, which can be a benefit if you have a very user group specific place you're trying to estimate use for or understand use patterns for. But it's really important to understand who the users are and what is represented in this data and who's not represented in this data. It's again, best if it's calibrated or validated. So as an example, I had a recent study here in Oregon at an area called Black Rock Mountain Biking Area. Mountain biking is in the name. And so we used Trailforks to see if we could use Trailforks post as kind of a proxy for visitor use levels. But we tested that by actually setting up a trail counter at various points in the trail and comparing our trail counter counts to the Trailforks data to see if they were comparable. And we found there was a strong correlation between our counts from our trail counters and kind of the posts from folks on Trailforks. So that gave us a little bit more confidence that we can use Trailforks data to understand use levels and estimate visitor use during our non-monitored times when we pulled those trail counters. It's less precise at really, really small spatial scales, as I mentioned. Like you wouldn't want to use it to count like people at one time at a like a view, but you can again use it for relative trail use levels. And it's also important to understand that these apps change in popularity. Some of you may have been familiar with the app Map My Ride, which kind of where you could map your bicycling trip and mountain biking, but then Trailforks came out. And so most folks now have shifted to Trailforks. So you just need to be aware that different user groups use different apps. There's some bias in the apps and that there's constantly new apps coming out that may become more popular from past apps. So to go through a quick example and to kind of illustrate some of these points I've made, we're going to quickly walk through a study, again, out of Australia. Catherine Pickering, one of the authors here, has done a lot of work with volunteer geographic information and with Flickr. So a couple papers from her work, where they looked at the VGI data from a couple different online platforms to look at relative use levels on different trails. And so what I'm trying to illustrate here is, again, that different apps might give you different data, and it's important to understand that. So here in the top, you can see this. These are the boundaries of a protected area. And these kind of shaded in areas are the trails that were being used by people from these different apps. So they downloaded data from MapMyFitness, and this is the spatial pattern. But when they looked at Wikiloc, which is also called Trails of the World, this is kind of another, similar to AllTrails, but I think used a little more internationally than in the US, we can see different patterns of use. So the Wikiloc data captured some trail use here in the northwest corner that was not captured at all by the MapMyFitness app. And we can kind of see similar things happening here in this other protected area where we see differences in patterns of use between the different apps. So understanding that different apps might be giving you slightly different data and making sure that you're using the app that's most relevant and maybe most used in your park And again, validating with some on-the-site data is key for using some of these VGI and crowdsourced data sources. I also want to show you kind of a really quick and low-cost way to use these VGI data sets. This is from Strava. This is a paper from 2019, but this is just showing how even without having to download the Strava data or put it into your own map, you can get some information about visitor behaviors. So this is from a protected area in Boulder, Colorado. Here on the left-hand side is just a kind of zoomed in map of some of their trail systems. So these dashed lines are the trails themselves. And then here on the right-hand side is just a screenshot, essentially, of the Strava Global Heat Map. So you could pull up Strava Global Heat Map. I don't even know if you need a Strava account, and kind of look at where folks are posting, like where they are saying they're recreating, and just kind of look at the heat map. And what the point was here is that just by looking at the heat map, we can monitor some things like off-trail use or the use of informal trails. So the purple, again, is where visitors are posting their rides or their runs to Strava. And we can see use on the designated trails here and here, but we also see quite a bit of use on these two trails, which are informal or social trails. And so this can help you monitor a little bit potentially of off-trail use, maybe get on top of where informal trail development might be happening, and get a sense of those use patterns in a way that's, again, very low cost. Okay, so that was social media data and volunteer geographic information data. Now we're going to spend a bit of time talking about mobile device data. As I mentioned, this is also known as cell phone data or human mobility data. So mobile device data, the most basic definition is that it is geographic data. So again, those X and Y coordinates, those points on a map of where you've gone, that is associated with a mobile device like a telephone or a tablet. The data comes from a couple of different sources. It can come from your phone's internal GPS, or it can come from something called location-based services. And I'm going to do just like a little bit of background on those differences because it's important for understanding the accuracy of this data and like where it's best used and maybe where it might not be as helpful. So your phone's internal GPS works just like a handheld GPS. It connects to satellites. So it requires generally an open sky, access to those satellites. In the ideal conditions, mobile devices with connection to satellites can have about 5-meter accuracy, best conditions. So that's about 15 feet. In typical situations where folks might be near buildings or under trees, it varies, but the accuracy is probably closer to like 10, 15, maybe 20 meters. And different devices have different accuracies, actually. There's some studies that have been done to say like which cell phones are more accurate GPS than others, but not going into that today, but it does vary by device. Location-based services, on the other hand, use cell towers, cell signal, Wi-Fi to determine location. So the location-based services really work best when there's good cell coverage. They can work if there's not cell service, but it's best when there is cell coverage. So the way this data is collected is essentially if you're navigating to somewhere using your phone's GPS, that data can be stored. If you have apps that use your location, that data is then also stored on your phone or within the apps potentially. So for example, I have an app on my phone that tracks my location because it turns on a camera where I can watch my cats depending upon if I'm home or not. So in the background, that app is checking to see, am I home or am I not home? And then recording that location potentially in the background. So what happens is vendors can then work with these apps and buy or get that information of those locations or that GPS data and have a data set essentially of kind of where your device moves as it moves with you. And there's many, many, many different vendors. I'm not going to dig into that a lot, but generally you're working with a vendor to get access to that data or to get access of that data analyzed. So they can work up that data and give you estimates of visitor use or visitor demographics. So often you're not paying for the raw data, you're paying for the data, but the data is summarized in a way that is useful and can help answer your resource questions. And just like some of our other data sources, these are, again, rapidly changing landscapes. So, you know, they change the apps that they work with, they pull the data. One of the vendors I've worked with a lot, Streetlight, has changed. They used to use GPS and LBS. Now they're shifting to LBS. So this is also something that changes relatively rapidly. In terms of the opportunities for mobile device data, it is highly precise. Again, our cell phones have some error that becomes more of an issue in certain situations, which I'll talk about later. But this is more precise than the social media data and the volunteer geographic information data generally. We can also really vary the spatial and temporal scales that we can collect this data at. So mobile device data can be summarized down to the day, where some of the other data sources we talked about are not really that great for understanding visitor use at the daily level. But maybe weekly, monthly, it's good. But mobile device data can look at visitor use levels potentially at the daily level, and potentially even smaller timescales. We can also get it at a variety of spatial scales. So we can essentially create a geofence, a polygon, where you're kind of collecting that data from, and that can be whatever size. So here on the right-hand side, I've drawn a polygon around a park I worked in Salem, Oregon, and I've gotten mobile device data for that entire park area within that polygon. And temporally, another benefit is you can go back in time. So this data set's from 2021. I got the data in 2021, but my study started in 2019, and I was able to pull cell phone device data in 2021 from 2019, 2020, and 2021. So I had data that matched the full range of the study that I was doing. Like all of our other data sources, it does reduce time and resources in the field, and there can be additional information like demographics or like a point of origin, which is kind of like the census block where the person maybe spends most of their time or where they started their trip. So right now, most of the literature says that mobile device data works best, especially in situations where you're trying to estimate visitor use or understand visitor behavior at kind of broader spatial scales, like the scale of an entire park or protected area. It also works really, really well in parks with porous boundaries, where it'd be really hard to install trail counters, where there may be lots of entrances and exits, where it's just really hard to monitor kind of all the ins and outs of a particular park or protected area. So that's a really great use case for this sort of data. Again, if you're interested in broad spatial patterns or network level questions. So I just kind of pulled a quick screenshot of the Angeles District. There's a lot of different state parks. If you're interested in understanding maybe how visitors used a variety of state parks, or if there's a closure for some reason in one, where they might shift their use, those types of questions are really great for mobile device data that we can't really answer with those other data types that I've talked about thus far. So these kind of broad scale visitor use estimations, places with porous boundaries, and these kind of network level questions are where I think mobile device data especially has its strengths compared to those other data types. Some limitations is, again, it's not suitable for all visitor use management questions. It's really powerful, but like our other data types, we don't have any context as to like why visitors are behaving the way they're behaving, what their motivations are, how their experience was. And so some of these visitor use management questions related to the visitor experience, we can't really get with mobile device data, or honestly with the other data types that were discussed today. It can be expensive. Most of the vendors don't kind of post their prices publicly. You need to get a quote. But this is comparatively one of the more expensive data sources that we've talked about today. And again, the price can really vary from vendor to vendor, how many parks and protected areas you're wanting to work with. In other words, how many like polygons are you wanting to pull data from? So the price can vary. Another limitation, and this has come up a lot in the research realm, but these vendors, these providers are often doing some of the analysis for you. So they are crunching some numbers from the location-based service data, from the GPS data, and spitting out an estimate of the number of visitors that you have to your park. or they are taking the data that might have a lot of error and snapping it to roads and trails and then giving you densities of use. And those algorithms, those approaches, those analysis steps are proprietary. It's part of their business. And so you can't necessarily get information about the assumptions that they're making or how they're doing that analysis. More and more companies are also using machine learning techniques, which is a really can be a really great way to work with this data, but there's a lot of assumptions built into machine learning. Again, that you don't necessarily know what's happening in the background compared to the other data types like social media and VGI, where you download the data and you get to do the analysis and make some of those assumptions. So just a kind of a process difference. And like all the data types I've talked about today, having calibration and validation data is still required for best practices. So not all mobile device data is going to work well in all places. And so being able to validate it and make sure that it's good for estimating visitor use or visitor use patterns in your park is a really important first step, or to provide context. So a couple other limitations. It does come with demographic data, but some research has shown that the demographics don't always match actual park visitors. That's often because the demographic data that comes with mobile device data, most often, and again, I have not worked with every vendor everywhere, but most often it's based on that kind of point of origin or that home location from that phone and the census block data from that place. So we're extrapolating our demographics from where we think that phone lives, essentially, and then matching that to our census demographics and extrapolating from there. But we know from most of our studies in parks and protected areas, in a lot of places, our park visitors aren't matching our census blocks. There's also some disparities in smartphone use and ownership. Most folks in the US, from Pew Research studies indicate that most folks in the US do have a mobile device, but we have less use of mobile devices in older populations and in some low-income populations. So we want to keep that in mind too. Some studies have also shown that the data can overrepresent the behaviors or use numbers of staff and volunteers. So if you have your staff coming there every single day and spending a lot of time, some of the numbers can get inflated from the mobile device data from that staff member's device constantly coming into that park or protected area. The spatial accuracy can become an issue where your park or protected area kind of butts up against urban centers potentially, or like shopping centers. And I'll show you what that can look like in an example in a minute. And there's the behavioral aspect. So, you know, non-local visitors might be more likely to use a GPS-based app when they're visiting your park and protected area compared to locals. Or sometimes folks might not want to bring their phone. If people are going to the beach and they're worried about their phone getting wet, they may leave their phone back in their car, and now you've kind of missed that spatial behavior of that group of visitors. So we just want to think about that behavioral aspect too. Some challenging settings are, again, I mentioned these and I'll illustrate some examples in a minute. Parks that are very close proximity to urban settings where the cell phone error can't necessarily distinguish a visitor to a park versus a non-visitor who might be in a nearby neighborhood or shopping complex. Parks with limited signal, again, because the accuracy is not going to be as good on that data as data from parks that have better cell phone coverage. Really, really small spatial scales, just like all of our data sets, doesn't work super well there. And again, not great if you don't have calibration data, which I think is a key takeaway from all of this, is this data is best used if you can have some on-the-ground counts or some on-the-ground surveys to collaborate with and validate your big data source. So to wrap up, we're almost done. I know you've been listening to me for a while. I'm going to show you a couple examples of mobile device data used in some studies, and then we'll kind of wrap up and have about hopefully 10 or 15 minutes for questions and conversation. So this is a study from Orange County, California. This was a study that I worked on where we wanted to understand where we might be able to use mobile device data and where it might not be as ideal of a data source for understanding visitor use levels and visitor use patterns on trails. So we had done a big study where we had a lot of on-the-site counts. We'd done visitor surveys, and we had done GPS tracking where we gave people GPS units to carry in the nature reserve of Orange County. And so we compared our on-the-site counts to the counts that a mobile device data vendor, Streetlight was who we worked with, gave us to see how closely their data and their algorithm, their predictions of visitor use matched our on-site counts. And this wasn't a huge sample size. We had 12 locations we were able to compare the data. The red bars are the Streetlight data predictions for visitor use levels. And on this y-axis, we have estimated mean daily visitation. So this is at the daily visitation level. And overall, what we found is that the median between our on-the-site counts and the Streetlight data was really close. There was no statistical difference. So for estimating visitor use, these were pretty good. And this was, again, at the scale of the entire park. So this worked out pretty well. One thing we did notice is that there was not as much variability in the data, in the Streetlight data, compared to our on-the-site counts, but the median was pretty close. We felt pretty good about using the Streetlight data for these parks for estimating visitor use during times when we did not have those trail counters out there. Then we wanted to look at on the trail use, like which trails folks were using most often and had the highest densities of visitor use for both folks that were hiking and folks that were mountain biking. So here on the top, and this is for the Laguna Coast and Crystal Cove State Park. Here on the top, we have bicyclists. So Streetlight can separate pedestrians from bicyclists, and we did the same with our GPS data. We have the Streetlight maps on the left. The darker the red, the higher density of visitor use. Here on the right is our GPS tracking data. And then down here on the left is the Streetlight pedestrian data, and here on the right is our GPS data. So one of the things we found is that generally on trail, the data matched in terms of relative use. So Streetlight was pretty good at predicting which trails were busier than others, even though kind of our overall density counts were a little different. One of the things we did notice, though, is that in some of these border areas, and up in here, the Streetlight data kind of overinflated use levels near neighborhoods and near shopping complexes. And so at these kind of border areas where our parks and protected areas started to bump up, and this was, I'm just showing you one example, this was also in some of our other sites. Some of those cell phone data kind of got, instead of assuming they were at home or in the shopping complex, that data got snapped essentially to a trail or a road in our park or protected area, and kind of what we think overinflated the use compared to our GPS tracking data. So just something to keep in mind if your park and protected area is kind of close to urban centers, there could be kind of this spillover effect from the mobile device data. Okay, so I'm gonna move through the last couple slides pretty quick, make sure we have time for discussion. This was a study, again, trying to validate using mobile device data in Yellowstone National Park. One of the key takeaways from this study is that it did a really great job of estimating use levels at kind of broad destinations, like how many visitors are at Old Faithful. However, when they looked at the demographics and they compared the mobile device data to demographics from surveys on site, they found that there were differences in age, differences in races and ethnicities, differences in income, and differences in country, like home country or home state. So in Yellowstone, they found that while it was great for estimating visitor use, their on-site validation of demographics did not match the mobile device data, and the recommendation was not to use the demographic data for understanding visitor demographics to Yellowstone in this particular study. So illustrating again the importance of that validation for both on-site counts and demographic data that might come from mobile device data. Okay, so to wrap it up, there are other sources of big data besides the ones I've talked about today, including reservation systems, apps that you can encourage visitors to participate in, connected vehicles, and there's some community science apps like eBird, iNaturalist that can be used to monitor more of the natural resource side. Today, we really emphasize kind of the visitor estimation, visitor experience side. And I did just want to put up a slide to quickly just cue people in to also the ethical and privacy considerations of these big data sources. You know, these are passively generated data. So visitors or the public are creating it. Visitors are creating the mobile device data by having their phone and having apps that have location-based services enabled. But the users still might not realize that their data is being used this way. And so there are some conversations in kind of the academic and research realm about, okay, how do we think about this, and how do we think about the ethics of this data, and what should we consider? And it's important to also note that while mobile device data is de-identified, the vendors are de-identifying it, you don't know whose phone it is. Social media data and the VGI data, like Flickr, Instagram, Trailforks, that can be tied to a username. And so that is not automatically de-identified. So you just want to be aware of that from like a privacy and ethics consideration. Okay, so take-home messages before we move to some discussion and questions. There's a wealth of this big data being generated every single day, and there are really some great opportunities and strengths for using big data in visitor use management contexts. There are various questions to consider when thinking about what you might use the data for. And some of these came from a paper that I referenced earlier, Dagan and Wilkins from 2023, which I'm happy to kind of point out that citation on the next slide. But things to consider is like, what is the best data source for your question or need? Is big data going to get you the information that you need to make a management decision or to estimate your visitor use? Or are there other methods that might be better? And then can you validate the data? So even though these minimize your on-site data collection, there needs to be some validation for best practices with all of these data sources. It's important to think about who the data represents and who it does not represent. Again, there's bias in all of these data sources. And then also, again, keeping in mind these ethical and privacy considerations, especially if you're thinking about using some of the data types that are not automatically de-identified. So with that, I know this is really hard to read. These are my references. There will be a fact sheet that's created from this presentation today that kind of summarizes all of this in kind of a short brief form, and all of these references will be in that as well. So don't worry about like jotting these down, but they are here. You could take a screenshot if you wanted. And to end, I would like to spend just a couple of minutes to hear from you all if you see opportunities with big data, and then I'll save the last 5 minutes or so for questions. So I threw a lot at you today. I really appreciate your time and attention and listening. And Madeline, I think we can stop the recording at this point and open it up for a bit of discussion.